All right, here's where we are. I'm at home. It is Sunday afternoon, and Colin has come in today and said that he doesn't feel good and has stayed in the bed all day. So I cannot go to work tomorrow because I have to take him to be COVID tested. So I cannot get to work to my camera, to my Elmo camera, to do a video, and I can Zoom from home. I can do that because I do have a laptop. But in terms of showing you all how to work out these problems, I cannot do that from home other than in this way, okay? So this is gonna be your instruction on how to do acceleration calculations, all right? I've got 5 examples. I'm gonna try my best to record it. I'm doing it with my phone with my left hand, and I'm gonna work them out with my right hand. It's going to be the most fun, okay? You all pay attention, and then I'll give you a few examples to do as an assignment, and then you can turn that in. Tuesday, if I don't have to, quarantine because of Colin, then I have that conference thing, so I'll have to leave some sort of an assignment, and then Wednesday I should be back if Colin's not COVID positive. All right, hold on, I'm moving. Okay, I'm gonna do the best I can, and y'all are gonna respect the fact that I'm doing the best that I can, okay? Okay, acceleration word problems, all right? Acceleration is a new formula that we're talking about today. I made some Google slide notes about it. I'm gonna upload those, and then I'm gonna upload this video if it works, okay? Like I'll put this video in the slides, maybe that'll work. All right, I've got the acceleration formula written out. Acceleration is equal to final velocity. Velocity is a direction that you're going in a speed that you're going in a particular direction, okay? Minus initial velocity over time. So final velocity minus initial velocity over time. Or another way of saying it is VF, which is final velocity, minus VI, which is initial velocity. The word initial means start or beginning. And then over time, T, okay? Another way of saying it, an even shorter way, is that triangle symbol means change in, so change in velocity over change in time. All 3 of these things are the same, it will tell you the same answer. So that's just 3 ways of saying the formula for finding acceleration, okay? Acceleration can be positive and it can be negative. So if I'm a car and I go and I speed up from 30 to 70, then I have a positive acceleration. I'm going faster. I'm going in the same direction probably, and I'm going faster, so I have positive acceleration. If I'm in a car and I reduce my speed, then go from 30 back down to 10, that is also acceleration, but it's negative acceleration. So your acceleration can be positive or it can be negative. I'm gonna work 5 examples, and 2 or 3 of them are positive and a couple of them are negative, okay? All right, I'm gonna move this out of the way. I've already got them written out. Y'all are staying with me. Oh, Jesus. All right, example 1. Let's see if I can turn this. Look at this, shadows. I'm sitting at my kitchen table. Jeffrey is on his skateboard and starts skating down a ramp. 10 seconds later, he is traveling at 20 meters per second. What was his acceleration? Okay, so I'm gonna scooch down here. I'm gonna write out the formula. Again, there was 3 ways to write it. So I'm gonna say A, which is acceleration, equals VF minus VI divided by time. VF is final velocity minus initial velocity. Velocity is just another way of saying speed. That's basically what it is, and we already know that V stands for speed anyway, okay? So I'm gonna drop down here. That's my formula. I'm gonna plug in my numbers. So VF is whatever his final velocity or speed was. I go back up there and look. Jeffrey's on his skateboard and starts skating down a ramp. 10 seconds later, he's traveling at 20 meters per second. So that's his final right there. So I'm gonna circle it and I'm gonna put VF right there. Okay, what was his VI? VI is initial. Initial means start. it doesn't give you another number up here except 10 seconds. So if Jeffrey is on his skateboard and he starts skating down a ramp, then that means his initial velocity was 0 because he was still, okay? So I'm inferring that from the word problem. It doesn't tell me that, but you infer it because it says he starts. So I come down here and I say A is equal to VF, which was 20 minus VI, which I'm inferring is 0, okay? Because he was sitting still, he started, divided by T, which is time, all right? I go back up there and look at my word problem. Time is 10 seconds. So I say 20 minus 0 divided by 10, which is time. Ronnie Anglin, my physics teacher, told me to do this every single time, so I write down the formula and I just trail it down the paper. So 20 minus 0 is 20 divided by 10. A, which is acceleration, is equal to 20 divided by 10. 20 divided by 10 is 2. You put your units of measurement on the end of it, which is meters per second. And I circle it because that's what he told me to do. Okay? All right, there is number 1. So using that formula, VF minus VI divided by T. Looks like my pen's about to run out of ink. Evan, find me a pen and bring it to me, please, and thank you. All right, second example says a car goes from 4.47 meters per second to 17.9 meters per second in 3 seconds. So there's a 3-part answer. First part says, did the car speed up or did it slow down? And you go back up there. A car goes from 4.47 to 17.9. 17.9 clearly is higher than 4.47, so it sped up. So I'm going to say sped up. All right. All right, should your answer be positive or negative? Look at the shadows of my hands. I feel like I could do like puppets. Should your answer be positive or negative? It should be positive because the car sped up. I told you earlier that acceleration can be positive or it can be negative. If the car had been going 20 meters per second and then decreased its speed to 5 meters per second, then that would be a negative acceleration. In this case, it did not. It went from 4.47 to 17. So that means that it's positive. Okay, thank you so much, Evan. I'm getting a cramp in my hand from holding this camera. So it's positive acceleration. I'm gonna say positive because the car sped up. Okay. I'm gonna try to make it through this one and then pause because my hand really is cramping. All right, calculate the car's acceleration. So I come down here and I say A, which is acceleration, is equal to a change in V over a change in T. Don't get screwed up because if I vary and do a different formula, it means the same thing, I promise, okay? So over here, I'm gonna just write off to the side. VF minus VI divided by T. This and this are the same thing. It's the same, that just means change in. So if I figure final minus initial, that does tell you the change in. So that means change in velocity over change in time, okay? All right, I'm scooching down. I'm gonna say A is equal to, all right, what is VF? I go back up there to my initial little question. A car goes from 4.47, so 4.47 is VF. No, I'm sorry, that's VI. VI is initial, like what was it going to begin with? That's your VI right there. To 17.9. So there's your VF. That's what it was going at the end. That's what it was going to begin in. That's what it was going at the end, okay? And then the time is 3 seconds. So scooch back out down here. And I say acceleration is equal to, if I'm using that formula, that, same exact thing. It's just that's a longer way of writing that, okay? I say V final was 17.9 minus V initial was 4.47. Put that over time, which is 3 seconds. I know that from the formula, from the word problem. All right, I say acceleration is equal to, I'm gonna go over here to the Chromebook, which you all can't see, and I'm gonna plug in the numbers. 17.9 minus 4.47. I would normally be doing this on my phone, but I'm recording on my phone. All right, 17.9 minus 4.47 equals 13.43. When I subtract those two numbers, it comes out to be 13.43 divided by still 3. So I'm running out of room at the bottom of that page, so I'm gonna scooch over here. A is equal to, what's 13.43 divided by 3? That is 4.476667. All right, I'm gonna say 4.48, because it's like a run-on 4.476667. And then you put meters per second. Acceleration, that's your answer. Okay, my hand is kind of propped on a stack of books, so I'm gonna rock on. All right, I'm moving this one out of the way. So there was your second example. Thank y'all for bearing with me. If my dog comes in here, I'll introduce you to my dog, the one who craps on the floor incessantly. I'm fixing to get rid of him, no junk. No joke, I'm gonna give him to some sort of rescue or something because they crapped on the floor again last night. Anyway, all right, acceleration word problems, example 3, okay. This is an airplane flying at a velocity of 610 meters per second lands and comes to a complete stop over a 53-second period. All right, part A says, did the plane speed up or did it slow down? So you gotta go back and read the problem again. An airplane flying at a velocity of 610 meters per second lands and comes to a complete stop. So did it speed up or slow down? It slowed down. Slowed down. The thing was flying and then it stopped. So it slowed down. All right, scoot you down here to B part. It says, should your answer be positive or negative? It should be negative because this is one of those examples of negative acceleration. It was going 610 meters per second and it comes to a complete stop. So if you come to a complete stop, you ain't going nowhere, all right? So that means that it slowed down. So negative because it slowed down. So the answer is gonna be in a negative, it's gonna be a negative number because it slowed down. Okay, so keep that in mind. The thing was flying and then it came to a complete stop. So it did accelerate, it just did negative acceleration. It decelerated, which is negative acceleration. You can still calculate that though, okay? All right, I don't have much room down here at the bottom, so I may have to extend onto another sheet of paper. So it says calculate acceleration. You use the same formula, even though this is negative, still the same thing, okay? So I'm gonna say A equals a change in V over a change in T. Somebody says, I don't know what that means. It means this, V final minus V initial over T. That and that are the exact same formula. It's just that's a shorter way of writing it. All right, I scooch down here and I say A equals, all right, change in V. This is how you find it. You say V final minus V initial. I go back up to the top. What was the V final? The velocity or the speed final is 0 because they stopped, okay? So your final speed is 0, so 0 minus, still got to put minus, V initial. I'm telling you the word initial means the beginning. If somebody gives you their initials, it's the first letter of their names. So mine would be ADL, Amy Denise Long. So initial means the beginning. So I go up here and I say, well, what was the V, which is speed or velocity? Initially, at the beginning, it was 610. I know that from the word problem. So V final is 0, V initial is 610, divided by T, which up there in the word problem, it told me is 53 seconds. You don't really have to do anything for T. You just have to kind of copy it down, okay? All right, I'm gonna scooch over here because I'm out of room on the bottom of the page. So I'm gonna say 0 minus 610. 0 minus 610 is just negative 610. Negative 610 divided by 53. You don't do anything to the 53 other than just copy it, okay? A is equal to I'm gonna go over here to my calculator. I'm gonna clear this out if I can figure out how to do it. Yes, right there. I'm gonna say 610. I did this on my phone earlier to do it, but now let me find the negative on here. Well, even if I can't find the negative. Oh, there it is, there it is. All right, negative 610 divided by 53 equals negative 11.5094339623. So I'll say negative 11.51 meters per second. Circle it. Right. That is still an acceleration problem. It's just that the plane, I'm sorry, my arm's getting tired. The plane accelerated negatively. So your answer at the end should be negative number. So that's called deceleration. It decelerated. It accelerated in the negative, which is deceleration. Same formula, change in V over change in T. All right, I'm flipping this over. That was your third example. Okay, I got 5 total examples. We're at 16 minutes. Okay, example 4 says a dragster, which is a drag racer, like somebody who's racing cars, in a race accelerated from rest to 60 meters per second by the time it reached the finish line. The dragster moved the distance from start to finish in 8.3 seconds. My arm's tired, I gotta prop it up. What is the acceleration? I'm gonna read it again. A dragster in a race accelerated from rest to 60 meters per second by the time that it reached the finish line. The dragster moved the distance from start to finish in 8.3 seconds. What is the acceleration? Okay, same formula. I go right here and I say A equals change in V over change in T. Again, at this point, y'all should be like, I know what she's doing. Change in V means VF minus VI over T. Okay, that and that, exact same thing. That's a short way of saying that. A equals VF, V final, the final speed or final velocity. I go back up there and look because I can't remember. A dragster in a race accelerated from rest to 60. So your final velocity or final speed that it got up to is 60. 60 minus what was your initial velocity or your initial speed. It doesn't tell you. It doesn't give you a number, but it says a dragster, which is a race car, in a race accelerated from rest. If you at rest, how fast you going? 0. You're not going anywhere. So the initial VI, which is your speed initially at the beginning, is 0. Okay, and then time, it tells you, is 8.3 seconds. So that change in time and time, that is the same. Like at some point later on, maybe when you get to like 11th or 12th grade physics, it might actually give you, time 2, time 1, or whatever. But for right now, just a change in time is time. You don't have to figure out how to change in it. You just say time. So the time is 8.3 seconds. I know that. It told me in the word problem. Okay? I'm scooching down. I'm saying 60 minus 0. I know that is just 60. Carry down your 8.3. So 60 divided by 8.3. Let me get over here on this Chromebook and clear this out. 60 divided by 8.3. 60 divided by 8.3 is 7.22891566265. I'm going to round that and say A is equal to 7.23, because the numbers would allow that to round up. So 7.23 meters per second. Circle it. All right. Acceleration. I got one more. We got one more problem. I'm telling you all, while I've struggled to turn this page with my right hand, there is always a way to do things. There is. There's always a way. You may have to come in the back door sometimes to get things done, but there's always a way. All right, example 5. This is my last one. It says a car slows down from 50.0, that's what that is, 50.0, meters per second to 20 meters per second in 6.0 seconds. What is the acceleration? Okay. All right. I'm saying A is equal to a change in V over a change in T. Over to the side. What I really mean is V final minus V initial divided by T. I come down here and scoochy the paper. I say A is equal to, what is VF? Go up there and look in the problem. A car slows down from 50 to 20. So your final, well, VF is like, what was it going at the end, okay? It's going 20. All right, minus your VI is what was it going at the beginning. So VI was 50. If it's going 50, then it slowed down to 20. So you say 20 minus 50 divided by T, which is 6.0 seconds. So now you gotta do the math and say 20 minus 50, not trying to trick you. 20 minus 50 is negative 30. If you take 50 away from 20, you get negative 30 divided by 6.0. Okay, you should be able to tell what that is without using a calculator, but if you can't, I'm telling you, a negative 30 divided by 6 is negative 5.0 meters per second. Circle it. So in this case, it was acceleration in the negative. The car was going 50 meters per second. It slowed down to 20 meters per second over the course of 6 seconds. So it did accelerate. It was just negative acceleration. So which is also called deceleration. You use the same formula to calculate that, okay? There's 5 examples. So you can watch this video over and over. If you need to, you can email me. I'm telling you, I'm being honest with you. I have to go at like 8 o'clock in the morning and get in line at the urgent care places, at a place, I gotta pick a place, and take Colin, and they said the first, I think 25 or 30 people that show up to get tested, that's what they test in a day. So I don't know that I'll be able to, check my email and stuff in the middle of the day. And I know I'm probably not gonna be able to do a live Zoom. So that's why I'm doing this on Sunday afternoon, to try to help you all, okay? So I'm going to upload some notes. I'm going to insert this video into the slides. That's what the notes are. You can use your online textbook to fill in the notes. It's not a whole lot of fill in stuff, but it is a couple of things you gotta fill in. And then the assignment for tomorrow will be to do, I don't know, maybe 5 acceleration problems, okay? So get those done, upload those in Google Classroom, and then we'll see what's going on Tuesday, all right? My arm's really cramping. I'm at minute 23, so I'm gonna stop this video and post it, okay?